Thank you all for being able to join us today. We appreciate you taking time out of your day to watch our workshop. I'm just going to go through a little bit of the housekeeping items before I turn it over to Melissa, who will be your main presenter, and Elaine, who will be helping with the presentation and also answering questions in the background. So I wanted to let everybody know that we'd like this to be an interactive session. So we encourage you to ask questions, and we ask that you use the Q&A feature on your Zoom panel to ask questions. And then we'll be putting the link to the handouts here in a moment in the chat, so you can just click on that link and access the files that Melissa will be going over during our session today. And just to let everybody know that this session is being recorded, and we'll also provide a link later in the workshop of where you can find that on our website after today. And then we also will be providing certificates of attendance to everyone who's joining us live today. So with that, thank you again for joining us for this Acids and Bases in the Virtual Workshop, or Virtual World Workshop. I'm going to pass it over to Melissa and Elaine.
Hi, everyone. Welcome again to our workshop. And we are, as Angie said, going to be talking about how to teach acids and bases in this virtual world that we find ourselves in now. Before we get deep in the details and into the nitty-gritty, I want to make sure Elaine and I introduce each other so you know who your panelists are. And I'm going to go ahead and let Elaine introduce herself first.
Hi, everyone. Welcome to the webinar. I'm Elaine. I may have talked or contacted anybody by email, so in terms of chemistry, so if you have any questions, like Melissa and Angie said, please throw them in the Q&A portion, and I'll do my best to respond through there. And if it's something that would be of value to the group, I'll let Melissa know that she can answer that question for the larger audience.
Great. Yeah, and so Elaine is our director of chemistry at Vernier, and she's one of the chemists. And I'm also one of the chemists here at Vernier. We've both been there over 10 years, and we both actually taught at the college level prior to coming to Vernier. And you'll find that's very common in the tech support science realm at Vernier. We're all former teachers, we're all former educators. And so we like to say Vernier is for teachers by teachers, because we're really here to help you all out there accomplish your jobs as easily as possible and give you all the tools you need to teach young kids about science, which we all think is super, super important. And so this virtual webinar is another way that we're trying to help that. In particular, we're going to be talking a lot about how you can do the acids and bases with your kids in a virtual setting like this. So we're going to give you a lot of different options. But before we get into all of that, I want to reiterate the housekeeping items that Angie mentioned in the opening. First off, use that Q&A feature for all the questions. If you put something into chat, we'll also see it there, but we're monitoring the Q&A a little bit more closely, so try and use that as much as possible. And if time allows, we're going to do some discussion at the end, so you can use that raise your hand feature and we'll unmute you and you can talk if that's something you want to do. So the goal of a lot of Vernier workshops is to always give the participants something to take away. And in this virtual setting, what we've made that into is a Google folder that has a ton of really nice resources for you to take away with to help teach acids and bases to your students. And in that folder includes this presentation, which has a ton of links and videos embedded in it. So make sure you see that and you can access that Google folder. Angie put it in the chat window a couple times there. So make sure you can access that because we're going to be looking into it in just a few minutes. You're also going to be getting a recording of this workshop emailed to you, so you'll have all the information you need to teach acids and bases to your students. All right, So to get started with this idea of virtual education with Vernier, I personally think a lot of educators don't go to our website often enough to see how much we have available for remote education. And honestly, it changes just about every week. So if you think you know, go there again and try it out. Just go to vernier.com. That's where I'm showing right now. And if I hit this big banner in the front on Explore Remote Solutions, I am asked to basically self-select what I teach. So I'm going to go ahead and choose high school and scroll down and see all the resources that are available for me as a high school educator. This first webinar here is a really nice general overview of a lot of the remote learning resources that we have available at Vernier. And David Carter, he's one of our people in our outreach team, and he's excellent at doing these webinars. So he's going to go super in depth in all the different remote learning options that we have available. I'm not going to go nearly into as much depth as he does in this webinar, so I highly recommend it. We are going to go pretty in depth into our brand new piece of software called Vernier Graphical Analysis Pro. So I'm going to skip over that for right now because we're definitely going to talk about it a lot in a minute. So some other resources we have available for you are Pivot Interactives. And Pivot Interactives is a really great resource for all different age levels, all different types of sciences, physics, chemistry, biology. What's really neat about it is it allows you to, every single video is like a different variable. So if you were trying to do acids and bases with your kids, you could pick different concentrations or different acids, and there's a video for each different acid, and the students have to watch that video and get the data from it and analyze it all within the same web panel that is Pivot Interactives. And there's a whole webinar that can teach you about that Pivot Interactives. It does have a 30-day free trial. After that, there is a cost associated with it. It's $5 a seat for high school and $10 a seat for college. But that's a really great tool for online learning right now. We also offer a Vernier video analysis. I know most of you here might be chemists, but a lot of chemistry people teach physics. Vernier video analysis is a great tool for teaching physics in especially Newtonian physics. You use videos to create mappings, and there's a whole webinar on that guy. Also has a free 30-day trial. And not only do chemists teach physics, but we also teach a lot of engineering and coding. So Arduino is getting really popular with that group, and we have some free activities there. But I'm going to spend most of the time right now talking about this free experiment and sample data library. And I think most of you were sent an email that has a link to this and to download, or at least navigate to the Google folder that we're going to talk about today. And this whole web page tells you how to use this data library if you haven't used it before, but it is a wealth of information. So if I go into it directly, I can see up here, basically I have lots of different options here as far as what I teach. I teach chemistry. And then how we've set up this Google, it's basically just a glorified Google spreadsheet, is we separate it by all the experiments in all of our books. And for almost every single one of them, one of the Vernier scientists took the data for the experiment as it's written and has posted it in here. So for instance, today we're doing the acid-base titration. If I click on that link, you'll see in that folder a file, which in most cases is graphical analysis. Sometimes it's Logger Pro, etc. But that is the file that contains the data that you want. You can send it to your students. And then the second file is an actual Word doc that has all the instructions written as if the student would do it. So you would send the student the Word document, and then you send them the data file, and they can edit that data, analyze it as much as they would as if they had taken that data themselves, and then answer all the questions in the Word document, especially if you want it. It's a Word document, so you can edit it as much as you want. You can put it into a PowerPoint that you're doing for your students on virtual learning. There's a lot of great flexibility in that. So definitely take a look at all of the experiments we have available for you. So that's what's in this column. This column is a video, if we have one, that's been posted to YouTube. It'll be over here. And in this middle column, this is the software that they used for the data analysis. So graphical analysis is pretty common, and that's our free software. But for chemistry in particular, there is also instrumental analysis, which is if you're using our mini GC or our cyclic voltammetry system to take data, that's the piece of software you use for it, and it's also free. You'll also see on here spectral analysis, which is the free software for taking data from our spectrometers, like the SpectraVis Plus. And then you'll also see Logger Pro. Logger Pro is not free. It is a one-time fee for a site license, and many of you, I'm sure, are very familiar with it. And what I want everyone to know about Logger Pro 3 that I'm not sure many people are aware of is that if you have it on your computer as an instructor, it is free for you to distribute that to all of your students, completely free. You just need to create a free account on our website and make sure that your website is linked to your school's account so that it sees that Logger Pro is your site license, and then you can just distribute it just like that to your students. Super easy to do. If you have any questions about it, again, put it in that Q&A, put it in chat, wherever you have questions about it, make sure you know that you can do that. Because a lot of instructors are having their students buy Logger Pro or use the 30-day demo or Logger Lite. If you have it on your computer, your school has a site license for it, you can send it to your students. And that's always been the case. So just making sure everyone's aware of that. Okay, so let's get into the name of the game today, which is acids and bases. I'm not seeing a whole lot of activity going on in the Q&A or the chat. Tell me, say hi, say where you're from. Let's get some interaction in there going. Have you already talked to your students about acids and bases yet this semester? Maybe where are you at with all that? Let us know. All right, so probably up to this point, if you are interested in this acid and base titration that we're going to try and teach, not only in a hybrid environment, so maybe you as the instructor are allowed to go to your classroom and do live videos like this for your students. We're going to talk about a really good use case for that, for teaching titrations to your students that way. But we're also going to teach it as if you're at home, like a lot of us are. Obviously, I'm at home, and that you don't have as many access to chemicals. We're going to talk about a couple different ways that you can teach that way. So hopefully up to this point, you have talked to your students some about acids and bases, or you've expected it in a previous course, what they are, you know, what kinds of pHs you get. And just basic characteristics about them. But now you've gotten to the point where you want them to do a titration and actually understand the acid-base chemistry, that back and forth, and why it's so important, why they teach it in general chemistry at the high school level, in AP chemistry, and in freshman chemistry, because you'll see it the rest of your chemistry career. So it's really, really important to learn about acid-base chemistry and neutralization reactions, how to determine molarities of different compounds, pKa's, all kinds of great stuff. And while we want to teach our students a lot about that, it's also important, that flip side, that a titration is not just for acids and bases. I know a lot of my students, when they would come to me like in upper division courses and I asked them what a titration was, they said to get the pKa of an acid. And it's like, no, you can use them. It's a general tool to be used in your chemistry toolbox. So I always like to remind my students or anyone that it's just another tool you have, like a spectrometer or a gas chromatograph. So that being said, we're actually going to do some live data today. So, oh my goodness, something I forgot to do. We're going to take a step back and, all right. So what I want everyone to do before we get too far ahead of ourselves, so graphical analysis is our free software. And I'm going to make sure I put the link into our chat there. If you're willing and able, maybe get a little crazy today, go ahead and download graphical analysis to your computer or your iPhone, your iPad, whatever you're using. Do it right now, because I want to have a really engaging session, and I have some fun activities planned for everybody. So go ahead and do that. And of course, if you're teaching this at home to your students, you would just have them come to this page and download it for themselves as well. All right, so I have graphical analysis already downloaded on my computer and open. And this is what it looks like in the background. And I'm going to be doing a titration today with a Vernier pH, Go Direct pH probe, and a drop counter. So these are Go Direct, which means they are Bluetooth or USB to any platform. So Mac, Windows, iOS, Android, Chromebooks. What I'm going to be showing today is with these Go Direct, but you can also, if I'm sure many of you have these cabled sensors and interfaces like a LabQuest Mini or a LabQuest, you can do everything that I'm showing today with these as well on graphical analysis. And the instructions for all that are in that magical Google folder that Angie put into the chat. So I've connected these sensors in my titration setup to my graphical analysis software. A couple things I want to point out before we get started with the titration is, especially if you're doing this with AP students, with honors students, I saw some honors people in there. And let's see what else is going on in the chat. Yeah, lots of AP, lots of honors, probably some freshmen, Gen Chem. You're going to want to do really quantitative work with a titration. So you're trying to get a pKa. You're trying to get a really precise endpoint to get really precise molarities and all that kind of stuff. But if it's the first time you're ever showing your students a titration and you know they're just going to get a bright peak solution instantly, you may not need to go this far. But if you're trying to get quantitative results, you definitely want to calibrate your pH probe first. And to do that, you click on the little meter here, click on calibrate. And I just calibrated this pH probe yesterday, so I'm pretty sure it's good. And the video of me calibrating it is in that magical Google folder that Angie put in the chat. And so I'm not going to calibrate it right here for you, but one thing that is really important to be aware of is this relative stability reading right here. So I'm in a storage solution right now, so it should read about pH 4. But I want to make sure before I enter that value of the known buffer, because I need to get out my two buffers, my 4 and my 10, that this value is stable. And the same thing is equivalent if you have one of the cabled sensors, that you want to make sure the voltage here is stable before you press keep. And that's all that value means. People put a lot of stock into it. It really doesn't. You just want to make sure it's stable before you type in, yes, I know this is a 4 buffer, I'm going to press keep. All right, so I'm going to cancel out of that. The second thing you want to make sure you do is calibrate your drop counter. So I enter the calibration screen the same way from the meter at the bottom, press calibrate. And this is a little bit different process. It walks you through the process, but what you do is you set up the drop counter in your titration setup and make sure that some kind of titrant is going through the drop counter, and it's going to count all those drops. you put a graduated cylinder underneath it, and then you're going to get a certain volume in there. So it knows how many drops it counted, you know the volume, you type that volume in here, and it does the calculation for you automatically. Now I'm going to show you why this is so important. So the default calibration that ships with a drop counter is 28 drops per milliliter. I calibrated this one yesterday, and I determined that it's 20.88. So that's a really big difference. And most of that has to do with this reagent reservoir that you're putting on top of the drop counter. So not only is it this reservoir, but it also depends on every single piece that you have connected to the reservoir. So what a lot of people will do when they've calibrated a reservoir like this, they'll put a piece of tape up here and put the calibration, that 20.88 or 21.2 or 28.3, whatever that reservoirs is, and put it on here so that you can just type it in like I just did. So another really good, helpful tip for all your titrations. So now I'm all set up and ready to go. I've calibrated my pH probe, I've calibrated my drop counter. My setup is, oops, hang on. I've got my titration all set up there. And I'm gonna go ahead and press collect first. Nothing is gonna happen until I open that valve to let the base go into the beaker through the drop counter. I have 5 milliliters of hydrochloric acid in that beaker with some water, and I have sodium hydroxide in the reagent reservoir above. So I'm going to go ahead and start my titration. All right, so the titration's going, and if you can't see the little red dot that's flashing from the drop counter beam being broken in that tiny little video that you're looking at, you can also see the data coming in here on the graph in graphical analysis. I don't want to make you watch this whole titration come in, and I promised that if you downloaded graphical analysis, we would have something fun to play around with while we're letting this titration work. All of you, if you just downloaded graphical analysis, have the free version of it, but we're going to give you a week's pass to play with the GA Pro version. And so right now, if you open graphical analysis on whatever platform you're using, and you can either just click manual entry or click outside the welcome screen, and you should see a screen just like this that has a little shield up here. So I hope everyone's seeing that. And this is asking for a GA authorization key. And so if you purchase it or you download the 30-day trial, you'll get a key for this. But we're going to give you a key right now. Elaine is putting it into the chat for you to access it right now for 7 days. So, all right, you do, if you have GA, you want to make sure it is the latest version of GA if you already had that on there. I see some people are not seeing that shield, but, and then Elaine just put that code in, so I'm going to use Elaine's code there. If you're not seeing the shield, you might not have had the latest version if you're already using one that you didn't just download. So try and update. To update GA, especially if you're on a computer, you can click on these little ... and do check for updates. So make sure that's up to date. You want to be on 5.2. All right, and now we have this little radio icon here. So I do want to make it clear that as an instructor, I want to share this data to you all the participants out there. So I'm going to set up a data sharing session. But for you, as the participants, as the students, you don't want to do what I just did. You want to actually click on the little untitled in the upper left-hand corner, click on new experiment, and then click on that second option of data sharing. Once you've clicked on that second option of data sharing, you want to type in this code that I'm showing right now. And this is what you as an instructor would do with your students. So you want them to connect to your session. And I'm going to go ahead and put that into the chat as well. That's the code for the data sharing session. And so now if you've connected, you should see on your screen a titration. So I'm hoping people are seeing a titration, and I'm going to go stop our titration since it clearly has passed the endpoint now. We got that gorgeous pink color, if you can see in the little window there. All right, some people are seeing it. Woo, that's so exciting. So I do have a little secret to share. This is the first time we've ever demoed this, especially in a webinar setting like this with as many participants as we have today. So please give us all your feedback on that. I'm hoping everybody saw it and has seen it and able to play with it. You do have this code now for 6 days, so you can play with all the features of GA Pro. But I do want to emphasize before I stop data collection, that this environment that I have just set up is ideal if you as the instructor have a laboratory or some way to take data live that you want the students to see you taking live. So you can have the camera on the setup and show them this is how you'd set up a titration, this is where the acid goes, this is where the base goes, ask them questions as you go along in a very interactive environment that you're trying to accomplish with your students right now in this crazy world, so that they can see the data come in live. However, it's not like they're going to see everything you're doing. So now once I stop data, they have control. They get to do the analysis and do the curve fits and the calculated columns on their own. So once I stop data, I want you all as the students to go find that equivalence point. So how would you do that? Play around with the data, figure it out. I'm going to show those of you who either couldn't get the image. I'm hoping we can do some troubleshooting, but if you're unable to do it by yourself, let's show you how you would do it with your students, or if you just wanted to show your students how to do it, this is how you would do it as well. And it's all within graphical analysis. You don't have to export the data out at all. Go from the pH column and click Add Calculated Column. So the first thing I want to do, right, is do a first derivative to find out where the fastest place that the rate of change happened. Column Y needs to be pH, column X needs to be volume. If anyone has already solved the where the equivalence point is, feel free to put it in. All right, and then we're gonna do, so I'm gonna add the first derivative on top. And it's a little messy over here. Can't get a really clear peak, so I probably wanna do a second derivative. So on the pH, add calculated column, I'm gonna do the second derivative. All right, so it looks like there's quite a few questions about where to put in the the code to join the session that I have already done. And so what you as participants, in order to join this session, click on Untitled, click on New Experiment. And I'm not going to do it because then I'm going to lose all my data. But once you do that, there'll be 3 options. The first one is like data collection. And the second one is data sharing. So click on data sharing. And now you're on a screen that says data sharing online, and it gives you a place to put in a code. And I'll show that code one more time. So put that in to that data sharing place. And I can even see how many people are connected here. So that's great. Several of you got connected, which is awesome. All right. Great, great, great. Good, 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 good. Okay, so I've put the second derivative in here. So, and it looks like some people already got the answer. But let's go into the second derivative one. So that's probably going to give me closer data, and I'm going to really zoom in where it passes 0. Nothing really touches 0. So I'm going to actually turn on the interpolate function and go in here and find where that second derivative crosses 0 as close as I can get it. And yeah, 5 milliliters. Wow, look at that. Awesome. So we had a couple people that that got that answer. Great. This is so exciting. Okay, so yeah, so that's the option if you are in that world where you want to actually take data and have students go in and analyze it and play with it and all that kind of stuff. Some of you may not be in that world, which is totally understandable. Some of you just may be like, I just have to send videos and data. We have a way for you to do that as well in GA Pro. And if you still have GA Pro opened, you can click on this view options. And if you'll notice, now you have a video option. Actually, I'm going to stop sharing first, because I don't want to mess anyone up. But you can, so even if I stop sharing, you all still have your data. So never worry, like your students immediately GA closes for them or anything. But when you stop sharing, they still have that data and they still have that file. So now you have a video option. This is a new thing for GA Pro. You can add a video directly into here. So we're going to go back to that magical folder that Angie put out. And I have several videos in here for you. I have that pH calibration, like I mentioned, a drop counter calibration video, and then this Chem A 7 video that we're doing. I'm going to right click and I'm going to download that video. Or maybe I already have like my own video as an instructor. I know lots of you guys are doing videos like crazy. So maybe you have one that you want to use, but I just click this import video. And then I go navigate to my downloads and I find that video that I just downloaded. And now it's in here. So I can just send this file to my students and say, here's the video of the strong acid, strong base titration. Watch the video. It has the, so you'll see in here, it has the exact molarity of the standardized sodium hydroxide. So, because that's what students need, that to figure out the exact molarity of the hydrochloric acid. It tells you exactly how many milliliters of hydrochloric acid were added. So students have everything in the video that they would need to answer all your analysis questions, to do all your data analysis and all that kind of stuff. And so right now, if I wanted to save this file, it would include the video. And so I could send it to students that way. We often get a lot of questions around saving in graphical analysis. It's pretty straightforward. You just do a file save or save as, you know, that's the same convention in other programs. But working remotely, a lot of people will just want like a graph screen. They want to know their students did, you know, this second derivative and zoomed in on it and got all that good stuff. So a great way to save data or export data another way is to export it as a CSV if people want to do it in Excel, but you can also export a graph as an image. So I'm going to put that in my downloads folder. All right, now that's saved. So I stole this from one of my coworkers, one of my chemistry coworkers. Thanks, Noose. This is his lab write-up template that he used when he was teaching high school chemistry. And I think it's a great asset right now in a virtual world. And many of you probably have your own version of this. But it's great for, you know, a Google Classroom type environment, and it has the title and your name and your partners, the purpose, the materials, you know, what the students did and their procedure, but then it has a place for data and graphs. So I can go in here and I can insert an image from downloads. And I get the students, you know, graph right in here. I can also have them put a link out to the GA file if they upload it to the Google land. And then the next page we do calculations. So we say, you know, how many milliliters of hydrochloric acid. This one was almost exactly 5, huh? Didn't most of us find that out? So that 5 milliliters was the end point. So they can do all those calculations to get the molarity of the hydrochloric acid right here. So it's great, great tool. Let's see, let's go back and see where we are. So that's kind of the gist of the 2 different ways you could be teaching. You could be teaching where you're able to do some hands-on stuff and give it to students, or you could just be giving them a video, and GA Pro will do that really well for you. So I'm just going to recap a lot of what we went over and what is in that awesome Google folder we're going to walk away with. A video. Yes.
There's one question that might be helpful. Someone is asking about the legacy export option in Graphical Analysis Pro.
Okay, why would you need the legacy export? So the legacy export is useful if you're using older versions of GA, or if you have a version that, let's see, because even GA Pro files will open GA files, and GA will, if you have GA and don't have GA Pro, you might want to use that legacy export, but they should go back and forth. You should be able to open a GA MBL file with an AMBL file, but definitely test it out. But the legacy export is used to preserve any features that you don't think might work in an old version of GA. Did I get that right, Elaine?
I think that's a very accurate description.
Yeah, that's it. That's a great question, and it is kind of misleading, but I don't suspect we'll need to be using that too much. So in the presentation that's in that folder, there's that video, the strong acid, strong base. I briefly showed it in the corner of GA there. You have a student version, so I went through and collected the data. Of course, if you connected to my data share, you can save this data for yourself. It wasn't the best titration, but it gave some decent results. Let's see, it wasn't too bad. This is a little bumpy in here in places, but the data in the file in your Google folder is really pretty, really slick, gives really good first and second derivatives. So there's a student version, which is just the data. So you can use your GA Pro to add a video into it if you like. But then there's also in that folder an instructor version, which has the data analysis that we just went through, the first derivative and the second derivative in the calculated columns. Okay, and so a little bit more information about GA Pro. It does, so right now you have that free 6-day trial, which doesn't count against your 30-day trial. So then you could still get a 30-day trial if you wanted to play with it longer. And then it is a site license. So what a site license means in Vernier land is that you pay that fee once. In this case, it's a yearly thing, and you get to distribute it to anyone in your school building or your college department. It can also be put on students' devices. And again, Graphical Analysis Pro, Mac, Windows, iOS, Android, Chrome. So all those students would see the exact same thing that you all just saw. And it's $69 through June of next year. I had a lot of videos about pH calibration and drop counter calibration. So this one is showing it with a lab quest. This is embedded directly into the presentation, but I also have links out to the videos in the folder there. Something else I like to share with people anytime I talk about a pH sensor, I want to show them all the troubleshooting resources we have available for them on our website. And there is a nice little spreadsheet in that Google folder that goes through a lot of troubleshooting a pH sensor. How do you calibrate it in all the different softwares we have? If it's not reading pH 4 in its storage solution, what should you do? Elaine, tell everyone what you should do if it's not reading pH 4 in its storage solution. Putting her on the spot.
I guess there's a few things you could do. One thing I would do is may need to be recalibrated. That's definitely something we would recommend. But our website has a bunch of FAQs that kind of go through the workflow of why it couldn't be reading it. One of the things we get calls on are the glass bulb is broken. Then it wouldn't be reading pH 4. And unfortunately, in those scenarios, we can't repair the probe. So I would highly recommend going to our website and looking at our FAQs because there's a good chance your question will be answered there.
Absolutely. And so this link out to this resource that is in the folder basically is just a compilation of all the FAQs on our website and what they relate to in terms of what issue you're kind of seeing. All right. And then there's, of course, disinfection. We've been getting a lot of questions about this lately. So we have a bunch of FAQs about this. Just be aware of the pH probes are made of ABS plastic, which is not compatible with a lot of harsh solvents. So you really just need to be using detergent, mild detergent, and wiping it. I see we have a question about some mold in the pH sensor. Use a mild detergent and just wipe it off. Make sure you clean out the storage solution bottle. Clean that out. Wipe it really good with detergent. Refill it with pH 4 buffer with potassium chloride. That's what's in this storage solution. Mold inside the shaft of the pH probe is very rarely actually mold. It's usually our older probes that we had were clear here that light could get through, and the silver chloride would precipitate out. So it was actually just black silver particles. Instead, a lot of people thought it was mold. If you get mold inside the little tip, you can clean this with some detergent, but that's about keeping mold out of here. So yeah, definitely replace the buffer solution about 1 to 2 times a year. Depending on where you live, some people, are more humid environments, you might need to do it more often, but it's a good thing to just sit them aside and replace that solution 1 or 2 a year. All right. And so I think we've made it through all the topics of discussion for today. Let me show what is upcoming in training. So we have 2 different training options right now in this virtual world. We have the fall virtual workshops, which you all are participating in. Thank you for coming. We greatly appreciate it. And then we have personalized online trainings that you can request a workshop here on our website. If I click on the fall virtual ones, I can see what's upcoming. So photosynthesis was yesterday. You're in this one today. Uniform circular motion for physics is happening tomorrow. You can register right here. We're about to post some for November. I know chemistry is doing one for organic chemistry, and then we're doing one for intermolecular forces and food chemistry. So those are our workshops coming up in November. So look in on this place on our website or check your email. I think we send some emails out about that kind of thing. But we're definitely we're excited about doing a food chemistry one and an organic chemistry one. So keep an eye out for that. And we still have quite a bit of time. So if anyone has any questions, feel free to raise your hand. We can let you ask them aloud or put them in the Q&A. And if you can't think of any right now, you can always go to our website. You can call in, email chemistry@vernier.com. We also have chat on our website. All right, so there's a question that comes in. Are there any free virtual labs to help during online teaching? So to answer that, I would go back to that experiment and sample data library that I talked about very early on in the session. And so this is if I go in here, I have free sample data and free experimental write-up for the students. So it's not, it doesn't always have a video. The only ones that have videos are over here. So this one does happen to have a video. And that is what I would point you to if you wanted free virtual labs. Some of our other options require fees, I guess. But that's what we have for free. Any other questions? How did everyone like the experience with GA Pro and the data sharing? Is that something you think you would use in your classroom?
Melissa, that's a good question that you might want to answer for the audience.
Yeah.
So if you have the Vernier lab books and you're using Chromebooks, how do you implement that with graphical analysis?
Great. So all of our lab books, almost all of them, have been updated to have instructions for graphical analysis on a Chromebook. So first thing, looking at the question here, so this person is using Vernier lab books with Logger Pro right now, and they switched to Chromebooks. So first thing you need to do is on all of your Chromebooks, put graphical analysis. It's free. It's available from the Chrome Web Store. And make sure you have that in all your Chromebooks. Great. So then the books have all been updated to have graphical analysis instructions. If you purchase the book at any point, again, our books are like site licenses. So once you purchase it, you have access to the electronic files basically forever. So every time we update the book, you get access to those new files. So the way you would access those, and I referenced to this earlier, and how you would distribute to your students, is to create a free account on our website. So now I'm logged into my account. I go to downloads. And it will see all of I have access to Logger Pro. I can distribute this to my students. I just click on that link at home. I have access to lab book electronic resources. So I have access to an advanced chemistry with Vernier book. I can download these electronic resources, and the graphical analysis instructions for all of the labs are in there. So that's how I would deal with transitioning from Logger Pro to Chromebooks. Yeah, you're welcome. What else? Any other questions? Anything else anyone wants to see in GA Pro? Or Oh, yeah, I guess while we have some time, we could talk a little bit more about the video aspects of GA Pro. If you happen to still have GA Pro up, what I'd like to show you is if I do, so this wasn't super exciting because it's just a video and a titration, which I mean, as chemists, we're all very excited by this, like, don't get me wrong. But a titration is what we in the Vernier land call events with entry data collection. So it requires knowing, basically having not time-based data, which a lot of chemistry people have. If you have time-based data collection, you can actually sync the video to the data, which is actually super cool. So I'm going to show this with another set of data. In fact, in GA Pro, there's these sample experiments. So you can click on this. And I'm going to look at some data that is time-based in the chemistry world. So maybe you are thinking about doing some intermolecular forces coming up soon. And one of the great experiments we have in our books is looking at the rate at which solvents evaporate with our temperature probe. So we have temperature versus time data. And you can see with the Graphical Analysis Pro, I have this replay button, this enable replay. If I open that, I see that now I have these controls up here for my video. So if I start my video up here, the data is coming in when the data started. So it's synced directly. So I can pause it here and I could be like, what's going on? And I can keep going. So that's pretty cool. It's great in a lot of different chemistry applications. And it reminds people a lot, if you ever did this type of data or video analysis in Logger Pro, it's trying to kind of get back to that. If you want to upload your own video and do your own syncing, you can do that as well in GA Pro. And you would do that all in the same kind of window. You can open up the little camera thing and say, I want to sync data with video, and my data set time is this, and my video time is this. In this case, it started at time 0, so it wasn't quite as interesting, but we can look at some other ones because we have all this sample data to explore. And I know Noose's favorite is the molar volume of a gas. And so this one, if I enable replay and show when the data, so because it's saved with the file, the video time is 37 seconds. So the video is going to play for 37 seconds before the data comes in. So let's go ahead and look at it. And this is really nice because it gives context. Oops, what happened? Let me just do them both at the same time, I guess. So this gives context for what the experiment is doing. So kind of like what we talked about earlier with the live data collection, this is showing you the video and showing you your students the setup, since they unfortunately didn't get to do it themselves. And so giving that context, and then the data should come in.
Melissa?
Yes.
This might be a good opportunity to answer a good question that came in. Someone would like to know that what can GA Pro do that GA cannot?
So GA Pro cannot do what you're seeing now. It does not have anything video related. So regular GA, the free version of GA, cannot do anything video related. GA Pro can. Regular GA cannot do data sharing to another graphical analysis. So I can't share the data I'm collecting with my students from GA to GA in the free version. I can only do that in the paid version. Moving forward, the paid version will also have user-defined calculated columns and user-defined curve fits, which the free version will not have. And that's all I know that is officially in there. So those are the big key items. It's the videos, the data sharing, and the user-defined calculations is what you get with Pro versus the free version. Yeah, so you all saw in the background there, the molar volume of a gas. The data came in as soon as we hit collect on the keyboard, and now it's not as exciting, but you can still see some kind of bubbling in there. The students get why the pressure is increasing, all that good stuff. So some questions are coming in about regular GA. So if you as an instructor, your school purchases GA Pro, you would want all your students to have GA Pro because that's the only way to get all those features. That's why it's a site license, so that if you as an instructor have it, if your school has purchased it, all the students can get it on their personal computers as well. And that's how we showed it to you in the beginning of how you would share that information with your students. You would give them a code, an authorization code, and now they have access to GA Pro. The big difference between GA Pro and video analysis. Oh, that's an interesting question. So a question came in, what is the difference between GA Pro and video analysis? So video analysis is you have taken a video on your phone of, say, someone shooting a basketball, and you want to tap along that and get the trajectory and do analysis of the video. GA Pro is a video of the experiment with analysis linked to it. Did I explain that well? Elaine, do you want to jump in? Hopefully that answered that question.
I think so. I think for me, somebody explained it to me in that when you're using GA Pro, you're linking your data to like a sensor, like in our case, a pH probe or a gas pressure sensor. Whereas in the video analysis, the sensor you're using is really the video because that's analyzing your data. So that's, from the way I understand it, kind of the main difference.
Yeah, that's a much more succinct way to put it. So thank you for that. Great. I'm glad that answered that question. What other questions are coming up? We have about, looks like 2 more minutes in here, but so yeah. I'll go ahead and stop sharing my screen and see if we get, feel free to raise your hand. If you have any questions, we'll be happy to let you talk. We were talking before everyone arrived, and a lot of us in tech support are having, and I'm sure just you as instructors are having a little bit more anxiety about these virtual ones because you don't get as much interaction with the users and the participants and what's working and what's not, and you don't get some of that banter that we're also that we all like so much. So but hopefully we answered all your questions today. Hopefully you walked away with some tools for teaching acids and bases in your virtual classroom. Yeah, don't forget about that Google folder. Go into it, find all those resources. There's tons of videos in there. There's lots of student write-ups, those resources for troubleshooting pH probes. Definitely don't forget about that. And if you have any questions, you can always email us at chemistry@vernier.com. Thank you, Angie. She said it before I could. Yeah, contact us at chemistry@vernier.com. We also have chat on our website. You can also call us. But yeah, email is probably one of most of our favorite ways to communicate with people these days. Yeah, and thanks for attending our workshop.